Hello, hi everyone. This is Tushar from Biotechnica. Welcome you all back to this Prerna series. In this series, we have been discussing previous year questions of NEET. I welcome you all back, and today I am back with some chemistry questions. This will be some fantastic chemistry questions. Please join with me as soon as possible so that you can gain knowledge from this and enhance your score in the exam. So as you know, only 3 more days are left for the exam to be there on the Sunday. So I hope you guys are preparing well for this exam. Hi, Sneha. Only 3 more days are left. So just in this period, you need to keep yourself calm, go through what you have done, revise all your topics properly. And in this time being, you should more practice PYQs and mocks. Now you should not take on any new chapters. So that would be disastrous for you. Okay. So I'll wait for a couple of seconds more and then we will get into the session. So today we'll be discussing some conceptual questions from chemistry that will help you to build your foundation for the exam. Hi Sazal, hi Dertek. Great to see you guys here. Hope you all guys are preparing well for this exam. Hi Asan. After this session, we can have any other doubts. Hi Matthew. So let's get started with this session with the first question. So the first question here for you, predict the correct intermediate and product in the following reaction. Here we have propylene. It is reacted with water, acidic H2SO4 in the presence of mercuric sulfate to give intermediate A, and that is giving us product B. So among this, you have to find the correct choice. So this is a good conceptual question from organic chemistry. You can try this question. You should try all these questions with me. At least you will develop the approach. You will know what all mistakes you are making. You will know how to tackle a question. So be with me and try solving these questions along with me. I'll wait for a few seconds. I can give you a hint over here. You can use oxymercuration. You can use oxymercuration over here. Asan is saying option C. Deotek is saying option D. Okay, other guys, please solve. Matthew, option D. Great, everyone. Okay. So let's understand this question. So what we have here propylene. Now, in the presence of mercuric sulfate, it will undergo oxymercuration. So what will happen? In the first step, the intermediate will be this with the OH group attached. So you know in oxymercuration, we have the addition of OH and H in Markovnikov fashion or in Markovnikov rule. So what does Markovnikov rule say? The OH will be attached to the carbon with least number of hydrogen. So the option A will be this, where the OH is attached to the least number of carbon. Now, once you have the enol form, since it is acidic medium, this enol form will convert to the keto form. Okay, so correct answer is option D. So what is happening? This enol form that we have, is converting into the keto form. So great, those who have answered D. So the concept here was Markovnikov rule. I can give you a shortcut trick to this. Rather than remembering the concept, you can just check for the stability of the carbocation. What you can do is you can think this group. So eventually what is happening? One pi bond is breaking. So you can just remove one pi bond from here, and instead of that, just think that once you are removing the pi bond, you can have a positive charge here and a negative charge, or you can have a different scenario here, a negative charge or a positive charge. So check for the stability. So in case if you get confused in the exam, you can just check the stability of the carbocation and answer this question. I hope it is clear for all. Let's move to the next question. So next question is, correct increasing order for the wavelength of absorption in the visible region for the complexes are, these are some cobalt 3 plus complexes, and you have to arrange them in the increasing order of wavelength of absorption. Try solving this question. So I can give you a hint. Based on this ligand, you can determine which will give more splitting, which will give less splitting. Okay, Sneha is saying option B. Just remember these terms when you are seeing in the exam, increasing order of wavelength. So from the smallest to the highest. Matthew is saying option A. Okay, so let's understand this question first. So what it is asking, it is saying we need to arrange this in the increasing order of wavelength. Now, what do we know? We know that from the spectrochemical series, we know the difference between a strong field and a weak field ligand. Now, cobalt 3 plus is constant. You can see in each and every complex, it is cobalt 3 plus. So what is different? The ligands are different. So what are the ligands that we have? We have En, which is ethylene diamine. It is ethylene diamine. We have En, which is ethylene diamine. We have ammonia, and we have water. Now, what do we know? We know from spectrochemical series that En is a strong field ligand. En is a strong field ligand in comparison to ammonia, in comparison to water. Now, this is the most important thing. So, En is a strong field ligand in comparison to ammonia and water. So, when this is put in a crystal field, it will separate more. It will create more separation. So, the energy difference of the absorption spectra for En complex with En ligand will be the highest, followed by ammonia, followed by water. Okay. Now, one more thing that what we know energy is inversely proportional to wavelength. Okay. So we know energy is inversely proportional to wavelength. So for En, which has the highest energy, will correspond to the smallest wavelength. So what do we need? We need increasing order of wavelength, from the smallest to the highest. So we will be having the smallest for En. We will be having smallest for En, followed by ammonia, followed by water. Followed by water. I hope you got this. So it's option A. Okay. Highest wavelength will be getting for the lowest energy, and lowest energy corresponds to water. Okay. Let's move to the next question. So the next question is, concentration of silver plus ions in a saturated solution of AgC2O4 is 2.2 into 10 to the power minus 4 moles per liter. What is the solubility product of this? Try to solve this question. So these are very important concepts: ionic product, KSP solubility product. In various questions, you get a mixed concept of this. So you should keep practicing these questions. So try solving these questions with me so that you can understand how the approach needs to be taken. Okay, I'll wait for a couple of seconds. Okay, I can give you one more hint. The KSP is the product of the concentration of the ingredients that this complex has. So Matthew is saying option D. Other guys, I hope you are solving with me. See, only learning cannot help you to get out this exam. You need to practice more PYQs. You need to understand and solve them. Okay, so let's solve this. So what is asked in this question? It is asking KSP. Now what do we know about KSP? KSP is the product of the concentration of the substituents that are present in this. So let's see what are the substituents present in this. Ag2C2O4. Now when this will dissociate, it will give 2Ag plus C2O4 2 minus. Do you get this point? When Ag2C2O4 will dissociate, it will give 2Ag plus and C2O4 2 minus. Now, what is it is saying? That the concentration of Ag plus ion in a saturated solution is this. So it is already given that the concentration of Ag plus is 2 into 10 to the power minus 4. Now, what will be the concentration of this? If this 2 corresponds to 2.2 into 10 to the power minus 4, so 1 mole of this will correspond to simply 1.1 into 10 to the power minus 4. Do you get it? Since this 2Ag plus corresponds to 2.2 into 10 to the power minus 4 moles per liter, so this single unit of C2O4 will contribute 1.1 into 10 to the power minus 4. I hope this point is clear. So KSP is the concentration of Ag plus square into concentration of C2O4. So it is already given 2.2 into 10 to the power minus 4 square into, now only we have got this 1.1 into 10 to the power minus 4. Now once you solve this, you'll get this to be 5.3, close to 5.3 into 10 to the power minus 12. Okay, I hope this question is clear for you. Okay, so the important thing, you should note the KSP formula. It is the product of the constant, and you should know how they are dissociating, because the KSP formula is same, but you should know how these complexes are dissociating and accordingly solve it. So the correct option is option D. Now moving to the fourth question. A gas is allowed to expand in a well-insulated container against a constant external pressure of 2.5 atm from an initial volume of 2.5 liters to a final volume of 4.5 liter. The change of internal energy of the gas will be. Try solving this question. This is a good question for thermodynamics. So we have a gas here which is expanded under external pressure, constant external pressure. Deartek is saying option B. Great Deartek. Other guys, I hope you are solving. Keep solving and try to develop an approach for these questions. I'll wait for a couple of seconds. Sneha is saying option B. Great. Matthew is saying option B. Okay, so let's understand what is happening. So what is given to us? It is said that we have a well-insulated container. Mark these words. It is saying a well-insulated container against a constant external pressure. So what we have? We have an external pressure of 2.5 atm from an initial volume of 2.5 liter to a final volume of 4.5 liters. Now it has asked to find out the change in internal energy. Okay, so what is the change in internal energy? From the first law of thermodynamics, we know change in internal energy is equal to heat added into the system plus work done on the system. Okay, so from the first law of thermodynamics, we have this. The change in internal energy is heat added into the system, it's positive, and work done on the system. So what here is a very important statement, well insulated container. So for a well insulated container, since it is insulated, no heat can enter into the system or heat can exit from the system. So Q will be 0. Okay. So Q will be 0. Since it is 0, so change in internal energy will be equal to the work done. I hope this point is clear. Change in internal energy will be equal to the work done. So what do we know? Work done is negative of P external into change in volume. So just plug in the values and solve it. What is the P external that we have? It is 2.5 into the change in volume. It's 4.5 minus 2.5. So it will come minus 5. Check the units. While solving physical question, you need to be very careful about the units. Okay. So it is 5 liter ATM. I can see the answers are given in joule. So you need to convert this liter ATM to joule. So for your convenience, I'm writing the conversion. It's 1 liter ATM equal to 101.3 joule. So it will come roughly to minus 505 joule. So the option B is correct. Okay. Those who have got this answer correct, great. You have been practicing a lot. So moving to the next question. Consider the change in oxidation state of bromine corresponding to different EMF values as shown in the diagram below. So this is the Latimer diagram for bromine. And in this, you have to decide which of these species undergo disproportionation. Which of the species undergo disproportionation? So this is a very good question, which involves the concept from electrochemistry and basic chemistry knowledge of disproportionation reaction and other types of reactions. Try solving this question. Great, Deertech. Deertech is saying option D. Other guys, I hope you are solving these questions. Matthew is saying option D. Okay. So let's understand this. Now, first thing to understand here is what is a disproportionate reaction. A disproportionate reaction is where the same species is undergoing oxidation and reduction. So when we have in a same cell oxidation and reduction, this will generate an electrochemical cell. So we can have electrochemical cell from this. So what do we know for electrochemical cell? For electrochemical cell, del G should be negative. Or in other words, we can say the EMF for the resultant cell should be positive. Now this is the crucial thing. To have an electrochemical cell running spontaneously, you need to have the potential to be positive. Now you can check these things. Here you have HBRO. So here it's +1 positive charge. Here it is 6. So you can find this BrO3 minus. Here you can take X plus this minus 6. So it will be +5. Here the charge over bromine is +5. And for bromine here it's 0. So you can see here the HBRO from +1 state to 0. So what is happening here? It is getting converted. So rather than, I can give you a trick. Rather than checking and solving and computing the all values and checking that for this resultant thing and this resultant thing, do we have a positive E value? You can change one thing. You can just check the EMF for the forward should be greater than the back one. Okay. Using this trick, you can easily solve it. For check for this BrO3 minus. So it is 1.5 volt and here it is 1.8 volts. So this cannot be the thing. For Br2, you can check. This is 1.0652 and it is 1.595. So this cannot be thing. So what is left? HBRO. So this will save time in the exam. I hope you all got this answer. This is option D. So the trick here is just check for each species, just check the electric potential ahead of this and behind of this. The ahead electric potential should be greater. Clear? Now the sixth question. Match the metal ions given in column 1 with the spin magnetic moment of the ions given in column 2 and assign the correct code. You need to find the magnetic moment of these complexes. Try solving this with me. So it is important to note here that at least you should know the atomic numbers of this transition first row elements, transition elements. I'll wait for a couple of seconds. So I can give you a hint. The formula for magnetic moment. Magnetic moment, mm, I'm representing this. Root over of n into n plus 2. Where n is number of unpaired electrons. Sneha is saying option D. Other guys, I hope you are solving. This is an easy question, but you need to be very careful while counting the number of unpaired electrons in it. Okay? Matthew is saying option A. I'll wait for a few seconds. Okay, let's try and understand this. So we have cobalt 3 plus. Okay, so cobalt 3 plus, what is the number of electrons? 27. So in cobalt 3 plus, it will have the configuration of cobalt 3 plus configuration will be 4s0 3d6. Okay, for chromium 3 plus, I'll move here. So the correct option is A. So for cobalt 3 plus, the electronic configuration is 4s0 3d6. For iron 3 plus, the normal for iron it's 4s2 3d6. So when 3 electrons are lost, it will be 4s0 3d5. Similarly for chromium 3 plus, generally chromium is 4s2 3d4, right? So since 3 electrons are lost, it is 4s0 3d3. And for nickel 2 plus, the general configuration is 4s2. Of course, argon is here, excluding the argon thing, 4s argon, 4s2 3d8. So 2 electrons will be lost here. So what we have? 4s0 3d8. Okay, now just take these configurations and write. So for cobalt, let's see for cobalt. 1, 2, 3, 4, 5. So how many electrons do we have here? D6. Cobalt is generally for 4s2 3d7. So 3d6. So 1, 2, 3, 4, 5, 6. So for cobalt, we have 4 unpaired electrons. Okay. For iron, similarly, for iron, we can do this for iron. So for iron, you will be having same 5. 1, 2, 3, 4, 5. For similarly, you can do for chromium. Similarly, you can do for nickel. And whenever you are getting this number, you can substitute and solve it. So it's an easy question. You just need to be very careful while solving it. So the correct option is A. Okay. Now moving to the next question. Which will make a basic buffer? So we have here 4 combination of things, and among this combination, you need to find which among this will give a basic buffer. Try solving this question. So which among this will give a basic buffer? Okay, I'll wait for a couple of more seconds. Okay, let's try and understand this. So the important thing is what makes a basic buffer. For a basic buffer, we need a weak base and a salt of it. This is important. For a basic buffer, we need a weak base and a salt of it. So among this option, you can easily search and optimize the time by checking which has the weak base. Okay, Deartech is saying option B. Matthew is saying option C. So just remember, there is a trick to solve this question. You can go and check if thing, but the basic fundamental thing you should understand that what makes a basic buffer. So we need a weak base. This is important. Weak base. Weak base. Just check in these options which option has a weak base. We need a weak base and a salt. So you can try solving all the options. So the first important thing, you can just immediately reject this option A because it has a weak acid and a strong base, so it won't be there. You can check this one. It has a weak acid and a strong base again, so it can't be there. Just check for the weak base. For option D, you can see it's a strong acid, strong base, so it won't be there. So only option C. Only option C is left, which has ammonium hydroxide. You can solve and try to check this. So what we have? Where we have HCl plus ammonium hydroxide. Okay, so we have here 100 ml of HCl into 0.1 molar. So how many millimole? 10 millimole we will get here. From ammonium hydroxide, what do we have? From ammonium hydroxide, we have 200 ml of this. Okay, of 0.1 molar. So it will be 20 millimole. Now when these things are reacting, eventually this HCl is my limiting reagent. So 10 millimole of ammonium chloride will be produced from this. Clear? So hence this is my weak base. Okay, and this salt. So weak base and salt will create a basic buffer. So the answer is option C. I hope this is clear for all. Now moving to the next question. When initial concentration of reactant is double, the half-life of a zero order reaction will it be tripled, it will be doubled, it will be halved or remain unchanged? So when the reactant is doubled for the half-life of a zero order reaction, how does it changes? Try solving this question. Deartech is saying option B, double. Great, Deartech. Other guys, I hope you all are solving this question. In this period, you have just 3 more days. So you should focus on practicing more and more questions. Rather than revising any new concept, you should focus. Matthew is saying option B, double. Okay, so let's understand this. So what we have, a zero order reaction. So what do we know for a zero order reaction? For a zero order reaction, the concentration at time t, Ct, will be equal to the concentration at time 0 minus rate constant into time. Since we have to calculate for half-life, it will be A by 2 and A minus Kt. So for first order reaction, for a zero order reaction, we have the half-life to be A by 2K. This is important. Great, Deartech. Correct. A by 2K. So when the reactant is doubled, you can see when reactant is doubled, it will be 2A by 2K. So it is getting doubled. Correct option is option B. Great, Deartech and Matthew. Moving to the next question. An alkene A on reaction with ozone O3 and zinc water complex give propanone and ethanal in equimolar ratio. Addition of HCl to alkene A gives B as the major product. The structure of product B is, This is a great question involving ozonolysis reactions for alkene. Try solving this question. So you have an alkene A. I'll wait for a couple of more seconds. Start thinking from the end of the product. What products do we have? Propanone and ethanol. Okay. Okay, I'll explain you what is happening here. So let's start with the products. We have propanone and we have ethanol. So what is propanone? This is propanone, the acetone, the common name which is acetone, this is propanone, and we have ethanol. What is ethanol? This is, so it is important to know the nomenclature also. This is ethanol, so this is propanone and this is ethanol. It is saying we have an alkene A which on ozonolysis gives us propanone plus ethanol. Okay, so before going to the solution, I'll give you a trick. So what do you know? So we generally know, let's say we have this alkene R1, R2, double bond, R3, R4. Okay, and when we treat this with ozonolysis we do. When we do ozonolysis of it, what do we get? We get, just the trick is break this double bond and attach oxygens on both sides of it. So we'll have R1, R2, carbonyl, and similarly for the other side also you will have, just let me clean the screen. So when you have R1, R2, suppose this is the thing that we are looking for and we're trying to do a ozonolysis of it. So Deertek is saying option C. Let's see. So just break this bond and attach oxygen to it. So we will be having R1 this plus R3, R4. The same concept you need to use. So what we have? We have this propanone and we have ethanol, CH3 double bond H. So just join these two. You just need to join these two. So what do we have eventually? We have this CH3, CH3. Now what is the second statement it is giving? On addition of HCl to alkene A. So what is our alkene A? So we have got our alkene to be A to be this. Here is H. Now when we are doing addition, HCl addition to it, you know, Markovnikov rule will be followed, or I just said you the trick. Just imagine this bond, you are breaking this pi bond and see which has the more stable carbocation. So this is the tertiary carbocation, this will be more stable. So the product will be, here Cl will be attached and here we will be having CH3 H. So the product that we are looking at is option 3. CH3, CH2, Cl is attached, ClC. So it's option C. I hope this is clear. Great, Deertek. Moving to the next question. For a cell involving one electron, the E0 cell is given 0.59 volt at 298 Kelvin. The equilibrium constant for the cell reaction is. So you need to find the equilibrium constant for this. Some values are given for your replacement, 2.3303 RT by F. You can take this to be 0.059 volt. Try solving this question. This is a very good question using Nernst equation. I can give you this hint. You need to use Nernst equation. E equal to E0 minus 2.303 RT by NF log Q, where Q is reaction quotient. Try solving this question. I'll wait for a couple of seconds. See what conditions are given to you. They have asked to find the equilibrium constant. So how can you find it? Math is saying option C. Great. Other guys? Okay, I'll explain this. So what they have said, at equilibrium. So what do we know? We know from Nernst equation E equal to E naught minus 2.303 RT by NF log Q. But at equilibrium, the cell potential is zero. E cell at equilibrium is zero. Okay, so what do we have? We have E naught equal to 2.303 RT. When we just, since it is zero, if we take this to the other side, it will be positive. So 2.303 RT by NF. And in this place, reaction quotient, it will be equilibrium constant, K equilibrium, since we are discussing this at equilibrium point. So it will be K equilibrium. So just replace this term from the value that it is given, 2.303 RT, 0.9. So just I'll do this. So E naught equal to 0.059 by N log K equilibrium. So what is the N for this? It is given. So N is the number of electrons transferred. So N equal to 1. N is equal to 1. Okay, just replace this by 1. So this will be 1. So what do we have? 0.59, the potential that is given for us, 0.59 is equal to 0.059 log K equivalent. Just if you bring it here, it will be log K equivalent will be 10. Now if you solve this, you know this, the base for the log K equilibrium is 10. So it will be K equilibrium will be 10 to the power 10. So we can basically write it 1 into 10 to the power 10. Okay. So this is the K equilibrium. So option C is the correct answer. I hope you understand this concept. You got this concept. So you just need to tweak the parameters that we have. You need to understand that at equilibrium, E cell will be 0. And the reaction quotient is changed. The Q will be the equilibrium constant. Okay. These two things were the take home from this. Let's move to the next question. Among the following set of reactants, which one will have, the question is, among the following complexes, arrange them. I'll write the question for you. Arrange them on the basis of enthalpy of hydrogenation. Enthalpy of hydrogenation. Just there is a correction in the question. Arrange this complex, the complex that we have. Arrange them on the basis of enthalpy of hydrogenation. I'm repeating this. You need to arrange them on the basis of enthalpy of hydrogenation. This is a very good concept for the organic compounds. Try solving this question. This concept can be at times very tricky, so you need to understand the fundamentals behind it. I'll wait for a few seconds. Okay, so we need to arrange them on the basis of enthalpy of hydrogenation. Enthalpy of hydrogenation. So what is this enthalpy of hydrogenation? The important thing is enthalpy of hydrogenation depends, it inversely depends on the stability of alkene. This is important to understand. The enthalpy of hydrogenation will depend inversely on the stability of alkene. So the thing that you have to do is you have to check the stability of these complexes. The more the stable it will be, the less the enthalpy of hydrogenation. Okay, so just check it. Complex 1, since it's an aromatic system, the order of stability, I'll find the order of stability. Dear Tech is saying option A. Great, Dear Tech. So the order of stability will be first. This will be, because it is an aromatic compound, it will be the most stable. Okay. Next, moving to this complex. These have some conjugation over here with this, and these are also in conjugation. So the next stable will be this, and the least will be this. The least will be this. Okay, since it has isolated double bond, so this will be the least. So this is the order of stability. So what you have to do for the order of enthalpy, just reverse it. So the highest will be for 3, then 2, then 1, the option A. Okay, I hope you got this question properly. The important thing for to note here is enthalpy of hydrogenation. Enthalpy of hydrogenation is inversely proportional to stability of alkene. Okay, great. Let's move to the next. The structure of intermediate A in the following reaction is, we have a cumene molecule here, and it is treated with oxygen to give option A, and then it is hydrolyzed to give this. So which among this is the intermediate A? Try to solve this question. This is a very typical question from this aromatic part where a cumene reacts with oxygen. Dear Tech is saying option B. Great, Dear Tech. Other guys, I hope you are solving these questions. Organic, inorganic, and be it physical, you need to practice more questions to gain your confidence in it. Okay. So yeah, let's understand this. We have a cumene here. In the presence of oxygen, it is important to know the between this CH bond, this oxygen molecule enters and there is oxidative addition. So when there will be oxidative addition, we will get CH3 OOH. This is the intermediate that we will be getting. Okay, it is important to note here that the oxygen molecule enters into the CH bond by oxidative addition. Okay, so what we'll getting option B 2, and then it later hydrolyzes to give phenol, and then this acetone. Okay, so it's option 2. Great, Matthew. Now moving to this question, an element has a body-centered cube structure with a cell edge of 288 picometer. The atomic radius is, from the solid state this question is there. So what is the atomic radius for a BCC type cell's edge? I'll wait for a couple of seconds. So I'll just, in BCC, body centered, at the edges we will be having, and also at the center of the cube we will be having. So when we see a diagonal passing through the opposite edges, so they will be aligned something like this. Dear Tech is saying option A. Great, Dear Tech. Other guys, try solving this. In the meanwhile, I'm trying to explain. Okay, so when we have this cube in a body center, there at the center of this cube, exactly center of the cube, we'll be having a atom, and on the edges of the diagonal we will be having, so they will touch each other. So what we have for this atom, we will be having 2R. Since it is on the edge, we will be just having the R part for this, and same for this R part. So the entire length from the edge to that edge, the diagonal will be 4R. Now what we know? We know the diagonal in a cube is √3a, where a is the cell edge. So √3a will be 4R, where R is the radius, where R is the atomic radius. Okay, so R will be √3 by 4A, where A is, it's given in the question, 288 picometer. Okay, I hope this is clear. So just need to remember that for a BCC, the cell edge diagonal is given by root 3A and it equals to 4R. Okay, so the correct option is 1, root 3 by 4 into 288 picometer. Let's move to the next question. The freezing point depression constant Kf of benzene is given 5.12 Kelvin kg per mole. The freezing point depression for the solution of molality is given 0.078 mole containing a non-electrolyte solution in benzene. So what will be the freezing point depression? It is asking what will be the freezing point depression. It's a great and a typical question from colligative properties. Try to solve this question. I'll wait for a couple of seconds here. So it is important to note here, freezing point depression is there. Boiling point elevation is also there from colligative properties. So practice question from this topics. Okay, I'll explain this. So what it is given? The Kf value is given to us. It is 5.12 Kelvin kg per mole. This is the Kf value. Okay, and the solution, the molality of the solution is also given to us. So always when you see a physical question, you see what all the parameters are given and what is asked and try to bridge the gap between them. Okay, so Kf value is given and molality is given. Now how to find this depression in freezing point? It is equal to I, which is Van't Hoff factor, into Kf into M. Okay, the important point to note here in the question is it's a non-electrolyte solution. Now, what is a non-electrolyte solution? Non-electrolyte solutions are those compounds which, when dissolved in solution, does not dissociate. The compound remains intact, so don't dissociate. For example, let's say NaCl. When this NaCl will dissociate, it will give Na plus Cl minus, so it is dissociating. This is the electrolytic solution. Okay, so for non-electrolytic solution, the Van't Hoff factor is 1. This is the important thing. For non-electrolyte, the Van't Hoff factor is 1. This thing you need to remember. Okay, so once we know this, so the TF will be I Kf M, where I equal to 1. So basically Kf into M. So what we have Kf, it is 5.2 into 0.078. Okay, so it's 5.12 into 0.078. Now if you calculate this, we will be getting option C as the correct answer. Okay, so just the important thing here, you need to note non-electrolyte solute. It is important, for which I is 1. Okay, moving to the next question. Consider the molecules methane, ammonia and water. Which of the given statement is false? Consider the molecules methane, ammonia and water. Which of the given statement is false? There are 4 statements. The first one is HCH bond angle in methane and in HNH bond angle in ammonia and HOH bond angle in water are all greater than 90 degree. The next one reads HOH bond angle in water is larger than HCH bond angle in methane. The third is HOH bond angle in water is smaller than HNH bond angle in ammonia. HCH bond angle in methane is larger than HNH bond angle in ammonia. Try solving this. Okay, Pankaj Kumar is saying option C. Okay, let's understand this. So we have a methane molecule here. Here all are bond pairs. Okay, now if we draw a ammonia, we can see a lone pair over this ammonia. Okay, Matthew is saying option B. Great, Matthew. and for water we have 2 lone pairs. Okay, so from BSPR theory, you know, lone pair repulsion. Just I'll clear this up. Lone pair repulsion is greater than lone pair bond pair is greater than bond pair. Okay, on this basis, on this concept, this question is based, so you can find this. Okay, so what is this? The correct option will be, it is given this. Just when you are reading these questions in the exam, be careful what it is given. Which of this given statement is false? So check which will be false. So HCH bond angle in methane, this methane, this bond angle in ammonia, and this will be all greater than 90 degree. This is the correct option. Okay, HOH bond angle in water is larger than HCH bond angle in ammonia. This is wrong, because in water we have 2 lone pairs, so there will be more repulsion, so this bond angle will be less. This theta, this bond angle will be less in comparison to what we have for methane. So the correct option is B, 2. Shubham Kumar, great. So moving to the 16th question. Equal mole of hydrogen and oxygen gases are placed in a container with a pinhole through which both gases can escape. What fraction of oxygen escapes in the time required for 1/2 of the hydrogen gas to escape? It's a good question from the diffusion chapter. Try solving this question. Important to note, hydrogen and oxygen gases are placed and they are passed through a pinhole. They're escaping through a pinhole. So what fraction? Okay, I'll just give you a hint. You can use Graham's law of diffusion. Okay, I'll explain this. So Graham's law of diffusion states about the rate of diffusion of gases. Rate of diffusion of gases. Okay, so it says rate is inversely proportional to the root over of molecular weight of gas. Molecular weight of gas. So this is how the rates are related of 2 gases. Let's say, suppose we have the rate of diffusion of gas O2 and the rate of diffusion of gas H2. This will be equal to root over of, since it is inversely proportional, this will go up. So it will be molar mass of H2 and molar mass of oxygen, which will be, for oxygen, for hydrogen it's 2, for oxygen that's 32, so it's basically 1/16, so it will be 1/4. So rate of oxygen equal to 1/4 the rate of hydrogen. This is what we have got. So the rate of diffusion of oxygen is 1/4 of the rate of diffusion of hydrogen. So it is saying what it is asked, the fraction of oxygen escapes in the time required when half of the hydrogen gas is escaping. So what we can see, so when 1 mole of H2 is diffusing, so 1/4 of O2 gas will be diffusing in that time, since rate is related in this way. So when half H2 will be diffused, so 1/4 into 1/2, which is 1/8. 1/8 of the oxygen gas would have diffused and escaped. So the correct answer is option A. Okay, I hope you got this question. So this was from Graham's law of diffusion. So with this, we have completed this session where we have discussed 16 questions from previous year NEET series and revise these questions regularly. Only 3 more days are left. So rather than taking up any new topic or new chapter, revise the concepts and practice more pre-PYQs. And in the last moment of this, believe in yourself that you have prepared a lot. So you believe in yourself that you can do it. Don't be harassed without any topic or without any distraction. Keep yourself composed. Best of the luck for your exams and prepare well. Thank you all. Thank you all for remaining with me for this session. Thank you.